Hi, it's Rob Fisher from RedStack here. Welcome to today's webinar on Flexible Modelling Advantage with John Frater. So John's one of our specialists, particularly on the mechanical manufacturing side. He specialises in Inventor, plant design, data management. Inventor is one of his key areas, and I'm sure he's got some great information to share with you today. He's got quite a bit of experience working across the Autodesk range of products and across mechanical engineering. So we are recording today's session. If you don't need to note everything down, I'll be sending out a link to the recording. And if you have any questions as we go, you can type those into your chat window or the questions window. We'll try and answer those as we go along. Otherwise, we will have time for questions at the end. So enjoy the presentation, and I'm going to hand over to John.
Good morning, everybody. John here. Yeah, as Rob said, I've been playing around with Inventor now for 12, 13 years. My first version was version 5. Respect to you guys who started before that. I've been at RedStack now for 9 months, and today we're going to have a look at the flexible modelling techniques in the latest version of Inventor, so that's 2016. Today's agenda, we're going to talk about different modelling options you have access to within Inventor. Then we'll have a look at the benefits of the users of the software. We'll talk about some of the business benefits. There'll be 3 videos running through this presentation, and then we'll have a question and answer at the end. Okay, so designing machines is no easy task these days. Products are becoming more and more complex due to product variations and complexity, all the nice shapes that people like. Not only are the parts you need to create becoming more complex, but the assemblies they are going into are becoming larger and more elaborate. Most of your designs can be driven with intelligent parameters to save time when creating a family of parts. You are routinely working with 3D CAD files from multiple CAD systems, websites such as GrabCAD, and a number of neutral CAD formats such as STEP, STL. Your customers require more stylized and ergonomic designs, not as an option, but as a standard part of the design process. Your CAD environment more than likely consists of 2D AutoCAD and at least 2 or 3 different CAD tools like Inventor or Alias or 3D Studio Max. Autodesk Inventor provides a professional-grade design solution with multiple modelling options. Traditional parametric modelling, direct editing for working history-free or working on non-native files, freeform and surface modelling for creative, ergonomic and stylised design. These modelling tools allow you to create the parts, assemblies and ultimately final designs that meet your customers' needs and save time. All of these tools and others inside Inventor help you make great products. The first modelling option you have is parametric. This is the traditional modelling technique that has been around since the inception of 3D CAD. Autodesk Inventor uses parametric modelling as its primary modelling technique. Parametric modelling is sketch or rule-based. This means your geometry is driven by a dimension, a rule, or a geometric constraint. Because parametric modelling is rules-based, it's very easy to create configurations of your models and assemblies. This saves time and money when creating similar components or families of parts. Geometric relationships can be defined which allow you to provide geometry from other components within the assembly. Parametric modelling allows you to build in the design intent you have for your components and assemblies from the very beginning of your design process. All of these tools and functionality make parametric modelling one of the most robust modelling options today. So this is a demonstration on parametric modelling. All of you with Inventor would have seen this before and done this many times. So I start off with a standard template that is designed either metric or imperial. Start out with a 2-dimensional sketch. Put down your lines, arcs and circles. Place your dimensions, so your parametrics are going to, your numbers are going to define how big the item is, what angles may be included, how long items are, how far apart they are, and then constraining these items geometrically just to make sure that they're in the right place. So these are placing the rules for the parametric design. You can see there that as you're placing these items, you get rules applied by default. The tangent there was the classic example. And then you can use a standard modeling or sketch tools within there to trim, extend, split, move, copy, rotate. Then of course you want to apply rules to this item to make sure that it's the right size. And you have your base sketch. From your base sketch, you generally make your first solid or your base solid with one of the solid modeling tools, creation tools. So you're just going to make that a certain distance, 30 millimeters, and you have a solid. Then obviously this clevis needs a bit of a hole through it so things can be attached to it. So again, using geometric constraints, you can then define where the hole is, the size of the hole, the extent of the hole, and once you have that, click the OK and you have the hole created within the part. So then a chamfer is applied between base and an edge so that it can be controlled so that it's the right size and angle. Another sketch is placed on one of the faces, so this is all parametric, so that if that face moves, the sketch will move with it. Puts in a dimension, so it will automatically dimension that distance, and he's going to place a point on the end of that so that you can then generate another hole. So we're going to generate a threaded hole at this point. So within Inventor there are a number of different types of holes, whether they're metric, whether they're ANSI, DIN, and it then defines the type of thread that's applied to that. Now he's making a countersunk hole. So this is all within the one hole dialog, how deep it is, what the angle is of the countersink. Once he's generated that, you can make a pattern of it to apply all the way around. So the rotation axis will be the axis of that hole. How many do you need, through what rotation, and you have a series of holes placed there. You don't have to do each one individually. Now, this is only half of the item, so he's going to make another portion of it by mirroring the entire solid through the back face, which then becomes the middle, and the next sketch will be the attachment. So they'll pop another circle on the center there of a particular diameter, in this case 60 millimeters, and extrude that a length. Now once you've done this, you'll need to define what this item is made of. Okay, you'll place a hole in there first, just to make sure that he's got something to attach, some meaning, some way to attach this item. It's going to be a threaded hole, just a plain threaded hole, 42 by 2, and it's going to make the thread only be a certain depth, or the depth of the hole be a certain depth and the depth of the thread a certain depth. So you can see the thread there on that last hole. Now he's going to make it nice and shiny. So you can either alter the color type, or you can actually apply a material. Now if you need to modify it, you just go back into the original dialog box, edit that item, and it gives you the same dialog box that you would use to create it. Now he's going to apply material, which in this case is going to probably be steel of some kind, an alloy steel, and it gives you all the relevant weights and volumes to do with that. That's the first video on parametric modeling. The next portion is direct editing. So the first modeling option you have is parametric. This is the traditional modeling method that's been around since the inception of 3D CAD. Autodesk Inventor uses parametric modeling as its primary modeling technique. And I need to just bear with me. So direct editing is a fairly new modeling technique made popular by applications like SpaceClaim. Direct editing is model or geometry based. This means no sketches or rules are needed in the creation or manipulation of geometry. Because direct editing is model-based, there is no model history. You simply push, pull, and drag geometry into position. Direct editing is ideal for working with non-native files, or what we call dumb solids. These files are typically imported from other applications or downloaded as step, IGES, or SAT files. Since direct editing is not history-based, it's very flexible when it comes to manipulating geometry. You can easily change geometry without worrying about breaking the part because of its history. And we have the second video. So this is on direct editing. So for an imported part, a SAT, a step, or an IGES file, you have this item comes in as a base file. So we're going to open a step file, and it's that particular one there. So we can then move faces, size items, apply diameters to make sure that they are going to fit the piece that we're generating. We can move faces. It's all done with this direct editing function. You also have the ability to move or recognize patterns, and you can also modify by placing in direct dimensions. So that was a nice quick one. The third option is freeform or surface modeling, and this has been around just as long as parametric modeling. The challenge has been making freeform and surface modeling easy to use. It's typically been used as a standalone surfacing tools. Similar to direct editing, freeform and surface modeling is history-free and model-based. Simply push, pull, and drag your geometry, create and manipulate. The modeling technique is ideal for creating ergonomic or stylistic shapes and components. Robust surface manipulation tools ensure you can create the shape or style you require for your designs. Freeform and surface modeling provides the ultimate flexibility when creating or manipulating 3D models. So we have this handle, which is what's going to be the object of direct modeling, direct modeling, freeform. So first of all, a shape's been generated, just a handle, and it's going to be opened as a part. We have these freeform tools in Inventor that allow you to mimic items that you may need to make very closely, so that you can then push and pull all these nodes within the model itself. In here you can also apply symmetry, and you then have the ability to apply standard items or standard features like fillets and chamfers onto the surface model, and you have your finished product. Relax mode sketching is actually not a modeling technique, as the name implies. It's a sketching tool. Its flexible nature makes it an integral part of creating any 3D model. Relax mode sketching does two primary things. First, it suppresses dimensions, and second, it suppresses constraints. This allows you to edit fully constrained sketches and automatically override dimensional values with ease. If you have ever had to work with a complex sketch, you'll appreciate this tool and add it to your list of favorite features. The great part about leveraging Autodesk Inventor is the ability to combine all of those modeling techniques at any time during your design process. When it comes to user benefits, the first one is pretty obvious. You and your users have access to more options to create the geometry your customers require. Secondly, parametric modeling is a foundation tool in any 3D CAD package. This means any user with any experience with any CAD tool can leverage Autodesk Inventor from day one. Powerful tools like direct editing allow users to edit and manipulate virtually any 3D CAD model regardless of the file type or source. It's all about the right tools at the right time for whatever designs you need to create or edit, period. Benefits aren't just reserved for the users. There's many business benefits as well when leveraging the tools inside Autodesk Inventor. First of all, parametric modeling allows you to create intelligent and reusable designs. Working with non-native files is a typical workflow in any design department. Autodesk Inventor offers flexible modelling tools to meet this challenge. Customer expectations are always rising for more innovative and complex designs. Autodesk Inventor provides professional-grade engineering tools that allow you to meet these design challenges. Save time and win more business with professional-grade engineering tools.